Now, just by the very nature of iterative solving, circular calculations in Excel, they are live solutions, but I'm going to kind of show you how we can implement a circular calculation to solve a pretty advanced case study. What I've got here is something known as the Colebrook equation. The Colebrook equation relates the friction factor in fluid dynamics, which is little f here, to the relative roughness. The relative roughness is this ratio epsilon over big DH, and the Reynolds number, which is RE. This equation was specifically set up because it can be solved nicely using iterative solving. And back in the day, several decades ago, when computational power wasn't as advanced as it is now, engineers would use this equation to solve for the friction factor. And the Colebrook equation can be used to set up these diagrams known as Moody diagrams or Moody plots. The math that I'm going to show you today can be used to create these Moody diagrams. So the Colebrook equation is set up so it can be solved using circular calculations. 1 over root f, we can replace that with just x, because you notice that that's found on the left side and on the right side in this second term in the original equation. So really what we end up with is this x equals an f of x. Whenever you can rearrange an equation to be x equals some function of itself, you should think circular calculations. Relative roughness is typically between 1 times 10 to the negative fifth and 1 times 10 to the negative 2. The Reynolds number is typically between 10,000 and 10 million, at least that's what I'm going to assume in this analysis. And the friction factor is generally between 0.008 and about 0.1. So I've set up my spreadsheet here. I'm going to have a guess, so we're going to guess x. Now remember, x is equal to 1 over the square root of f. So if I use a guess of f of about 0.01, then my initial x is going to be equal to 1 divided by the square root of 0.01. Now the function of x, I'm just going to plug in this second equation. So I've plugged in this equation here in terms of my guess, which is x, and the known relative roughness, and the Reynolds number. So I've got this equation. And right now, x does not equal f of x. So we set up iterative solving, and I say x equals the output, so the new input is equal to the output, but they're all linked, and so you end up with this big circular calculation. And I've already enabled circular calculations in the File, Options, Formulas menu, and we converge on a solution. So this is x, this is not f. So I'm going to use this equation over here to get back out my f. So f is equal to 1 divided by x squared, and when we do that, we get a friction factor of about 0.02. So that means at a relative roughness of 0.001 and a Reynolds number of 1 million, the friction factor is about 0.02. Now this is a live solution. If I change the Reynolds number here to 1E7, then this automatically updates. It changed a little bit, so let me go down to something like 1E4. So it changes the friction factor to 0.03. And I can also change the relative roughness. So I want to show you how we could then set up a big table. We're going to do a two-way case study. I've got Reynolds number here ranging from 1 to the 4th up to 1 to the 7th. And I've got the relative roughness between 1 times 10 to the negative 5th and 1 times 10 to the negative 2. Now we can set this up using a data table tool, a two-way data table. The upper left cell here has to be, this is a reference for where on the spreadsheet I'm going to get the variable that's going to populate this table, and that's the friction factor. And then I'm going to highlight this entire region, and I'm going to go into Data, What If Analysis, and Data Table tool. The Reynolds number goes into something known as the row input cell, so that's cell B8. We have a column input vector here, which is the relative roughness. The relative roughness goes into cell B7. Now when I press OK, for each combination of Reynolds number and relative roughness, it's going to go through a bunch of rounds of iterative solving to calculate the friction factor. So let's go ahead and boom, it goes through that very quickly and calculates the friction factors at those different conditions. It's an advanced implementation of Excel using circular calculations. Whenever you can set up your equation that you're trying to solve in terms of x equals f of x, then you should think circular calculations. Thanks for watching.